fascinating mystery of the origins of the universe still holds among its secrets the fundamental laws of nature. The signals which reach us from space, interpreted in the light of recent progress in physics, enable us to study the first moments in the life of the universe and to expand the frontiers of knowledge. In the depths of the highest mountain of the Apennines, these men are engaged in an unprecedented scientific enterprise. The realization of underground physics laboratories beside the tunnel of the Gran Sasso of Italy. The project, conceived in 1980 by the initiative of Professor Antonino Zichichi, at that time president of the National Institute of Nuclear Physics, won at once the approval of ANAS and the international scientific community, who saw in the new laboratory the ideal conditions for the study of natural radiation, being sheltered there from low-energy cosmic rays. In fact, there exist extremely rare phenomena of enormous scientific importance which can be studied only in underground laboratories, protected by great thicknesses of rock that attenuate the flux of cosmic rays, which continually bombard the Earth, and which would disturb, on the surface, the detection of the more interesting signals. In this sense, the Gran Sasso laboratories will favor the new course of fundamental physics. The work, entrusted by the Italian Parliament to ANAS, was commissioned to the COGEFA Society, already present on location with all the experience of its own specialized workforce, having had carried out the construction of the Gran Sasso tunnel. Entering the 10-kilometer-long tunnel from the L'Aquila side, the cover of the rock overhanging the two lanes of the motorway increases progressively until it reaches, at 6 kilometers from the entrance, a thickness of 1,400 meters under the peak of Mount Aquila. It is here that an impressive shield of limestone rock guarantees the cosmic silence necessary for the quality of the experiments. In September of 1982, 3 exploratory drillings made from the left tunnel confirmed projectual assumptions and gave start to the work. A long-awaited moment which promised to renew the age-long challenge between man and mountain. Here, the technicians of ANAS and COGEFA found themselves confronted with extreme difficulties due to the exceptional dimensions of the work and the particular hydrogeological environment of the Gran Sasso. For the excavation of the 3 great halls, 100 meters long and 20 high, a technical solution of notable operative efficiency was adopted. A passage 6 meters in diameter was drilled to reach the height of the roof. The passage was then expanded to the dimensions of the half section. The application of a mantle of spritz beton fortified by 3 layers of electro-soldered metal netting ensures stability along the contours of the excavation, which is progressively strengthened by means of systematically placed anchorages of stainless steel, each 8 meters long, positioned a short distance one from the other. 34,000 meters of this special anchorage, like a series of nails, guarantees the security of the cavity, increasing the cohesion to the rock. With the progressive reinforcement of the cavity, the half section is advanced for the entire length of the projected profile. Using the same technique, the excavation is then continued down to the floor level. The technique used allowed the application of a thin layer of spritz beton, offering a further protection to the laboratories, since a great thickness of concrete would have generated a level of radiation incompatible with the precision of the experiments. During all phases of expansion, systematic drillings for a total of 1,500 meters of borings constantly guaranteed the security and regularity of the work, which was also controlled by instrumental checks. But the projectual and executive coherence is revealed also in the secondary structures, such as the deacceleration and waiting lanes connecting the laboratories with the adjacent motorway tunnel. Here, a series of supporting ribs in concrete, fortified by a sturdy steel grid, modified the profile of the tunnel, which in the connecting stretches is almost rectangular. In the realization of the laboratories, 800,000 kilograms of steel were used. An adequate layer of concrete, strengthened by steel, supports the impressive security doors that circumscribe and protect the more important areas of the work. In 1987, the excavation was concluded for a total of 180,000 cubic meters. The 3 laboratory halls were ready with an ample furnishing of services and infrastructures. The tier tunnel for heavy transports, the automobile tunnel, the network of emergency passageways, the interferometer station. It is at this point that the finishing touches and the mounting of service equipment began. The lining of the 3 halls, protected by an impermeable sheath, was equipped with aluminium ribs and special insulating panels of fiberglass and polyurethane. The particular functional character and safeness of the fireproof materials used guarantees the thermal insulation, the luminosity, and the inalterability of the halls. The ventilation of these large spaces is handled by a system capable of supplying up to 80,000 cubic meters of fresh air every hour. Activated by a pumping plant located on the Thermo side, it consists of a complex system of conditioners which ensures adequate environmental climatization for the workers and scientific instruments. While skilled workmen were still putting the finishing touches on the refinements and to the equipment, groups of specialists, with the aid of the arched cranes installed in the 3 halls, began constructing the huge experimental apparatus destined to study many phenomena on the double frontier of the infinitely small and the infinitely large. The experiment LVD employs hundreds of tons of liquid scintillator and aims to detect the intense flux of neutrinos emitted in a stellar collapse. The number and the distribution in time and energy of the neutrinos are in fact linked to the mechanisms of the explosion of supernovae, as well as to the properties of the neutrinos themselves. Macro is an experiment dedicated principally to the detection of magnetic monopoles. Moreover, it is a true and proper astrophysical observatory which studies the elementary particles generated in the cosmos. The detectors, which allow the measurement of the passing particles, are liquid scintillator counters. The particle generates an emission of light, which, collected in photomultipliers by means of these mirrors, is transformed into an electrical signal. Thousands of wire chambers are used to precisely localize the passage of charged particles. The data collected by the detectors of the apparatus are processed by a series of electronic circuits and sent to a computer which stores the data on magnetic tapes for further studies. The registered events are presented in real time on a graphic screen. On this display is the schematic representation of the macro apparatus, and the points which are lit represent the signals produced by the passage of cosmic particles. The GALEX experiment proposes to measure the number of neutrinos emitted by the sun. The sun produces the energy which warms us by means of nuclear fusion reactions, in which are produced numerous neutrinos that reach the Earth, where they can be detected by underground experiments. The measurement of the number of neutrinos is important not only for a better knowledge of our sun, but also to improve our understanding of the neutrinos themselves. In these huge containers, 100 tons of a solution of gallium chloride are destined to be the target sensitive to neutrinos. The atoms of germanium, the element into which the gallium is transformed by the effect of the neutrinos, are withdrawn from the solution by a refined system of extraction and purification. It is interesting to note that the GALEX experiment must be able to reveal the daily production of 1 atom of germanium from the 100 tons of solution. The experimentation in the Gran Sasso confronts also themes of geophysics, from terrestrial tides to the prediction of earthquakes. The laser interferometer and the studies of acoustical wave emission pick up, using different techniques, the voice of the mountain. Other than the large experiments, the laboratory conducts other research of extreme precision on very rare processes like double beta decay and the stability of the proton. New apparatus of sensibility never before achieved give birth to a new phase in the studies of solar neutrinos and the dark matter of the universe. We have seen the national laboratories of the Gran Sasso as they are now, but ambitious programs of expansion, supported by international cooperation, already outline the future of this great hub of research. A new Italian state law, sensitive to environmental protection, has made it possible for ANAS to plan the expansion of the present underground area and the construction of a service tunnel 5 meters in diameter, independent of the motorway tunnel, in order to link the underground halls and the external laboratory building. A modern complex set with elegance, in perfect harmony with the beautiful countryside of the Gran Sasso. In this complex are the offices, technical services, and the data processing center, which, by means of high-capacity fiber optical cables, is connected with the instruments in the underground laboratories. Through these fiber optical cables pass radio, telephonic, and television communications, and above all, scientific data, which can be transmitted in real time to universities and research centers all over the world. The administration, other than coordinating the activities of the laboratories, promotes and hosts meetings and international scientific conventions, involving itself in this way in the life of the University of L'Aquila and in the traditional culture of the entire region of Abruzzo. This film has narrated the birth in the work area of Kojafar Impresit of the largest underground laboratory in the world, destined with its scientific acquisitions to give an answer to the fundamental questions of nature, and to support, through these very conquests of research, the united cooperation between nations. And this will be the most exciting success of the challenge hurled from the Gran Sasso to the frontiers of infinity.